All right, this is section 10.1. We are now starting to utilize our factoring. And here we go. All right, so you don't need to write notes on this first slide. So just like when we could take a fraction, the numerator and the denominator, and break it down into prime factors, right? So like the numerator would be 2 times 10, and 10 breaks down to 2 times 5. You with me? And I could break this down to prime factors by 2 times 12, and 12 breaks down to 2 times 6, and 6 breaks down to 2 times 3. So do you understand how I can break that down into prime factors? And then what we can do is we can reduce common factors. We can cross-cancel common factors. When I'm doing that, I'm left with an actual 1, not 0. Because if everything disappears, make sure you realize you're left with the number 1. 2 over 2 equals 1. And then we really can reduce our fraction to 5 over 6. Okay, that's one way we can do it, is just by cross-canceling our common factors. So if we have something like, so to reduce common factors from the numerator, we reduce by canceling common factors from the numerator and denominator. So in something like this, if I expand it out, right, it's 5, there's 3 A's, there's 2 B's. We can cross common factors out. We can cross a pair of 5's out. We can cancel a pair of A's, another pair of B's, another pair of B's. But I asked you to learn it a different way back at the beginning, right when we came back from the strike, and that was by slashing, doing our slashing and dashing method. So if I want to take out a factor of 5 out of the numerator, I'm left with 1, and out of 35, what are we left with? 7. And what's the greatest amount of A's we can take out? 1 A. So A to the first, and what's left in the numerator?
A to the second.
A to the second, and here I'm left with 1. What's the greatest amount of B's we can take out of the numerator and denominator, Nicole?
2.
B squared, say. And what's left in the numerator? No. When I take B squared out, when I'm taking 2 B's out, what's left?
1.
1. And when I take B squared out of here, what's left? B in the denominator. Wherever the bigger number is with the exponent, that's where the extras are left. So in the numerator, we're then left with 1 times 1 times A squared. And in the denominator, we're left with 7B. Does everybody remember how we did that before? Okay, so let's keep going. Now you guys try the next one. I only want you to do number 1. Please do not attempt number 2. I do not want you to start with bad habits. Only do number 1. Deposit. So, we can cross cancel. What can we cross cancel first? How about a 6? And out of the 10, what can we cross cancel? Yep. 2, and we're left with
3 and 5.
3 in the numerator, 5 in the denominator. We can take how many x's? 1 x in the numerator. I'm left with x, and in the denominator 1. You can take how many y's? We're left with y cubed, so it should be 3x y cubed over 5. How many people got that correct? Okay. All right, so now, the one big rule, pay attention. Pay attention. The one big rule that you have to remember when we're doing this is you cannot take a piece of a binomial. I cannot do this x and this x. Why could I do it up there? Because there were no plus signs. They were all part of the same term. They were all part of the same factor. So what we must do is we have to factor. And how would I factor that numerator? How would we factor that numerator? Okay, so what do we do? How would I factor that numerator? Go, Jamie. A 5, and then it would be 5.
Times the quantity of 2.
Good. 5 times the quantity of x plus 2. Now, when you have a binomial and you want to cancel it out, it has to look exactly the same. You cannot take a piece of a binomial. It's like canceling out a piece of my arm from my body. The binomial, everything goes together. The only way you can cancel out that binomial is if it looks exactly the same. And since x plus 2 is the same as x plus 2, that can be canceled out. And then we're left with 5. So what's going to happen is you factor first, then cross cancel. Okay? Questions? You cannot take a piece of a binomial. So let's look at this first one. You don't necessarily have to, well, you can write it if you want. If I were to simplify the first one, it just stays the same. I can't cross out the 3's. But here I can. I can cross cancel and I'm left with x. Now let's take an example and just put a number in and show you why. If I put a number in and then I end up with, let's say 4. We have 7 over 3. Can anything be canceled? Once it's simplified? No. But here if I put in 4, it's 12. And can't we divide that by 3 and we're left with 4?
Yep.
So do you see when there's a plus sign in it, you can't cancel out those 3's. You have to do the operation first. So if there's a plus sign, you can't cancel out common factors. Yes?
Couldn't for the first one you just cross the 3 and the 3 out? And then
No, because really, you have to first do order of operations here. This really simplifies to 7.
and then the one on the right.
Here?
Yeah.
Yes, you could. In the second one, which isn't that the same answer?
Yeah.
Right. What?
If you cancel out the... Oh, wait, no, never mind.
You can't do it here because there's a plus sign. You have to simplify it.
Yeah.
Here, you can cross cancel before you simplify if there's no plus sign because we can cross cancel a common factor. Okay? So now let's try that. Let's add that to our work. So how are we going to factor the numerator of the first one, Julia? What? It's not a perfect square. It's a difference of squares, and so it factors to times. Good. And you know what? When you're doing this, I want you to work like this. My PowerPoint doesn't, but I want you to work. These are expressions. Do not add. I don't want you to go horizontally. I want you to go that over 5x minus 25. This numerator factors to, she said, x plus 5 times x minus 5. Step 1, step 2, right? What does the bottom one factor to? Go, Chloe.
5. So
5 times.
quantity of x minus 5.
Good. X minus 5. Now, can we cross cancel anything?
Yeah.
What can be cross canceled?
X minus 5.
The binomial x minus 5. Can I cancel out the other two 5's?
No.
No, because it's a piece of a binomial. I can't take a piece of a binomial. So we end up with x plus 5 over 5. Okay? I want you doing it like that. Okay? Step 1, step 2, step 3, step 4. Because eventually we're going to add an equal sign and solve these. Okay? Create equations. Can I continue on? Okay, let's try the next one. Let's go 3x squared. You want to try the next one on your own or you want to do it together? Okay, pause the recording and try it on your own. Okay, so step 1, what do I do for the numerator, Nicole?
You can factor the 3 out.
And what's left?
X squared minus 9.
And can that be factored anymore?
Yeah.
What does it become?
3, x plus 3, x times quantity of x minus 3.
Good. And in the denominator, how do I factor that? What multiplies to negative 21 and adds to negative 4? Brianne?
Negative 7 and 3.
Okay, so that factors to?
X plus 3 times the quantity of x minus 7.
Good. X plus 3 times the quantity of x minus 7. Now, what gets cross-canceled, Noah?
You can cross cancel x plus 3.
Good. And we are left with 3 times x minus 3 over x minus 7. Okay? And that's it. We're done. Okay? That is as simplified as it can get. We're not trying to solve for x. We're just reducing the fraction, like reducing 20 over 24. Does that make sense? All right, let's move on. I don't want you getting in the habit of going equals, 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 equals. Okay. Okay, so remember we were doing this before. What would be the opposite of 7? Good. Opposite of y? Opposite of x plus 3.
Negative x minus 3.
Yep, negative x minus 3, right? The opposite of y minus 8. Remember this?
8 plus 8. Negative y plus 8.
But we flip it around. The negative times y minus 8 makes it 8 minus y, remember? If I need to flip something around, I just factor it as negative 1 times the flip. Right? Okay, what would this be the opposite?
2x.
3 minus 2x. What's this one going to be, everybody?
5x minus 6.
Okay, you get the idea? All right, now, how do I rewrite this as a product of negative 1 and its opposite? Negative 1 times the opposite of negative m is? What's the opposite of negative m? Okay, does that equal this?
Yeah.
Yep. So what would I write here? Negative 1 times what? What's the opposite?
Negative d.
Does that equal what I started with?
Yes.
Okay. Rewriting it as a product of negative 1 and its opposite is the equivalent. Okay. What would this be? Negative 1 times what?
X plus 4. X plus 4.
Good. What would the next one be? Negative 1 times
Negative b plus 3 minus
3 minus b. Flip it. What would the next one be? Nicole. Negative 1 times what?
5 minus 2x.
Perfect. Do you see how this whole thing is equivalent to that? It's just another way to write it. What would the next one be if I need to flip it around?
Negative 1 times 1 minus x to the 7.
1 minus x squared. Okay, next one, Noah.
It would be negative 1 times y minus 6.
Good. Next one, Julia.
Negative 1 times 7a.
Perfect. You get the idea? So if you need to flip something, just rewrite it like this when you're factoring. Okay, so let's factor our numerator. I've got x squared minus 9 over 3 minus x. Okay, so on the numerator, how would I factor that? X minus 3 times x plus 3. Okay, in the denominator, okay, I need to make this look like one of those two so I can cross cancel. Yes. Negative 1 times, how do I flip? What happens when I do negative 1? X minus 3. Now we can cross cancel. Now you're left with x plus 3 over negative 1, which if I were to multiply that, divide everything by, it would end up being negative x, negative 3. It's the same thing as multiplying by negative 1, right? So you could write it like this or like this. I assume just stop like there. Why go another step? It just eats time. Okay? So now let's try the next one. You guys get it? You want to try the next one on your own? Go. Pause the recording. So how do we factor the numerator? You guys are working from right the way I asked you to, even though my PowerPoint's going sideways. Okay, how do I factor the numerator? How do I factor it? Yes.
So, I factored it, I got x plus 5 times 100 and minus 6.
Good. And then the denominator?
I got 6 minus 10
6 minus n times 6.
plus n.
Good. Okay. Okay, now, it looks like there's something we can cross cancel. What can we do to the denominator to make it become the opposite? Okay, go. Multiply by -1. I only need to do it to one of them. So I'm going to make this one right here become the opposite. I might end up, I'm going to make this one right here become the opposite. So I can still put the -1 at the beginning, and then I'm going to have 6 plus n, and then flip it around, right, to n minus 6, because I factored the -1 out here, right?
How could you not put this in the first one?
Because that, if I do the opposite of the first one, it becomes -6, -n, and I don't want that. I want the flip of something. These are both, okay, this and this are both positive. This right here is exactly opposite of this and this. That's the one I need to be factored, the opposite. I don't need it to be -6, -n. Do you understand? See how they wrote it. So I'm doing the -1 on the denominator and plus 6. So you see they just put the -1 right here, but we're really just flipping this one around. Okay, do you understand that? If I wanted to flip the other one too, I'd have to multiply by another -1. Okay? You could have done it, and now we can cross cancel. Okay? We can cross cancel, and what are we left with?
N plus 5
Over.
-1 times the quantity of 6 plus n.
Perfect, and you can just leave it like that. Now, let me just show you off on the side. I could have factored the -1 if I noticed it right away. Like I could have right here, let's pretend I don't have any of that. I could have gone right to n plus 5 times n minus 6, and then factored the -1 and been n squared minus 36. And right away jumped to this. Do you understand? I could have factored the -1 here right away in the beginning. Or I can factor it here when I see I have an opposite. You guys with me? Okay. Okay, let's try some now. Now we're going to add some of the other kinds of factoring. Remember we had, when I have a lead coefficient like that, there's no GCF. What do I do with the 2?
Multiply them.
And so what multiplies to -6 and adds to 1? -3, positive 2. -2, positive 3. So this becomes, I'm going to first factor it before I put it in. It becomes x squared plus x minus 6 becomes x minus 2 times x plus 3. And then we have to divide it by what? Divide it by what? 2. And we get x minus 1 times 2x plus 3. Okay? So this is going to become x minus 1 times 2x minus 3. You with me?
Yeah.
Okay, I kind of do that off to the side, my factoring, because that was a little bit more in-depth. I couldn't do it in my mind.
Isn't it 2x plus 3?
Yes, sorry, plus 3. Okay, I'm going to erase my scratches and just go right to. Now, notice on the bottom, it factors to 1 minus x squared. Okay, what would I do now? Factor in negative 1, and in the denominator, and what's it going to be?
It's going to be
Negative 1 times
quantity of
1 plus x
times x minus 1.
times x minus 1. Do you see how it flips it around, you guys? Just that one part. Now notice, the negative 1, they moved it up top. Oh, they did it up top. That's fine. It's the same thing. If I put it on the bottom and flip this around, or I can factor the negative 1 in the numerator and flip this one around. But I can still cross cancel it. Doesn't matter where it's at, right? So we are left with negative 1 times 2x plus 3 over 1 plus x. Okay, denominator, what do I do first? Step 1. How about Noah?
So first.
Numerator, sorry.
Oh. So first, what you would do is you would do GCF.
Which would be
2.
more. 2x.
Oh.
And what's left?
You get x squared minus 100.
And in the denominator?
You would do GCF and it is 10. X.
Good. And what's left?
10 minus x.
Good. Can I do any more factoring?
No.
Hell yeah.
Yeah, it's x.
Sorry.
Oh, yeah.
Shouldn't be saying that in my recording.
100 is...
So it's 2x. Whoops. I never talk like that.
Sure.
Actually, I don't, do I?
You can.
Okay, how do I factor the other part of the numerator?
X minus 10 times the quantity of x plus 10.
Okay, and in the denominator, it's 10. What do we want to do?
Multiply
It's 10,
We'll factor it by
10 minus x. We want to flip it, right?
Yep.
So let's make it, I'm going to take out a negative right there, and then what it's going to do is make it x minus 10. Do you understand? I made it a negative, and that flipped it around to x minus 10. Right? I needed it to be the reverse, and so now we cross cancel. We get 2x on top. Oh no, there's more that can be cross canceled. What else can be cross canceled? The 2 goes into 2 once and into this 5 times, and I can take the x out. So what's left in the numerator?
X plus 10.
And in the denominator, negative 5 times x minus 10.
No, just negative 5.
Oh, negative 5, right. Negative 5, right. Good. Okay, questions? I'm sure theirs would have been much cleaner and neater. Let's see what they did. Yep, we got the same thing. If you want to distribute the negative to the numerator, it goes to both parts. Yes?
We have to do both of the homework, the wrap-up.
No, wrap-up is not homework. If you want to study for it tonight and just do some of that, that's fine, because I'm not checking 10-1 homework till the end. All right, the domain. I did not get to this with the other classes. So the domain is the list of possible values for the denominator. So in 5x equals, if I factor this, this is, what is x allowed to be? We are in fraction mode. What is the granddaddy rule for fractions? What is never allowed to happen in a fraction? How about thou shalt not divide by 0? So what x is allowed to be, is, hold on, I need to finish this. It can't be a 0. So what would make it equal 0? If x equals 0, or what other number?
4.
Okay, don't cross cancel. You figure out the domain before you cross cancel. This says simplify and state the domain. But you have to figure out your domain here. At this point, before you've cross canceled. Because what would give you a 0? X times x minus 4, right? The x could equal 0. And what would give you, make it equal 0 here? On this part.
Positive 4. 4.
Positive 4 or 0 would be the domain. So x can be any number except for
0.
positive 4. Well, x is an element of the reals, but x can be any number or except for 0 or 4. Let's factor the next one. Okay? What would give me a 0 here? In 2x. If x equals 0, so x cannot equal 0. And what's going to give me a 0 here? X cannot equal 3. Now we can cross cancel and we're left with x plus 3 over 2x. But the domain is x is an element of the reals, but x cannot equal 0 and x cannot equal 3. We factor again.
Attention students, the library is closed today, nutrition and lunch. Once again, the library is closed today, nutrition
Okay.
and lunch.
At this point, what is the domain? What is x not allowed to be?
It's not allowed to be negative 2 or 5. Or
Negative
X.
2 or 5? No, just negative 2 or 5. That's it. It can be 0, because 0 plus 2 would not, it just cannot be negative 2 or 5. So it's any real number, and it can't be negative 2 or 5, and then the x minus 5s cancel. But do you understand the point where you determine the domain?
Yes.
Is before you factored. Okay? And that is the lesson.